IT infrastructure for Industry 4.0. New IT infrastructure and networks are how IIoT devices can communicate. Without updating IT infrastructure, Industry 4.0 is only a pipe dream. Here are a few essential Industry 4.0 IT terms. Cloud computing. At this point, most of us are familiar with the cloud, from cloud-based software like Google Cloud, iCloud, Dropbox, and Microsoft 365. More and more of the applications we use daily run in the cloud. The physical equipment that powers cloud environments is typically spread across multiple physical IT facilities worldwide. Cloud computing uses cloud technology not only for storage, but also for high bandwidth computer processing. This infrastructure means IIoT equipment can send data to a cloud computing system where AI can perform automated data intelligence in real time and store the information in a central cloud system. Cloud computing decentralizes a company's computing systems, providing better security, up-to-date systems, and data storage redundancy. It also merges multiple data streams in one location, closing the digital thread and communication loops. 5G and Industry 4.0 networks. Real-time cloud computing and storage of data require more robust integrated networks than existed in the past. Facilities need new hardware to enable data-intensive network capabilities. Some of these IT technologies are only now emerging on the market. 5G technology will significantly expand the capacity of wireless networks. With peak speeds up to 20 gigabits a second, 5G opens the door to new technologies that were impossible to implement in the past. Compare those to the peak speeds of 4G wireless, which has a real-world peak speed of 100 megabits per second. 5G and other emerging network technologies are at a point where IIoT is becoming a reality. However, without a robust networking strategy, it is impossible to implement Industry 4.0 technologies. Internal networks and enterprise networks. Internal networking is the connection of network devices that communicate together in a closed communication loop. A closed communication loop is when machines rely on other machines' data to operate independently from external systems. Think of a group of manufacturing machines that depend on each other to operate. The communication is only between these machines, which is a closed loop of communication. One apparatus may handle materials, another one cuts the materials, and finally, the last device punches out the widget. These devices are automation ready since they communicate together on a network. Enterprise networking is when network devices communicate with systems outside of their direct closed loop of communication. For instance, the computer program that runs the material handling, cutting, and punching machines from the previous example may communicate with other systems within the manufacturing facility. It may also communicate back and forth with systems outside the manufacturing facility. In this scenario, the manufacturing system can run at the optimum speed based on other manufacturing machines' production capacity. The system can also send production information to a central hub network, managing material inventory and purchasing. It can also send data to other systems that analyze potential production delays and communicate to a management team the cost of production slowdowns. This process is an example of an enterprise network. Edge computing. The amount of data communicated by sensors within large-scale facilities often exceeds the current networking capacity. Edge computing allows internal networking data processing to happen at a facility. Thus, only important information is passed through enterprise networking for processing in the cloud and sent to a central system, reducing the network's bandwidth burden. Cybersecurity. Since writing this article, there's been several really high-profile ransomware takedowns from cronies and criminals that have cost big companies some serious money to get their data back. So this is definitely a topic to be paying attention to if you are trying to implement or get a Industry 4.0 initiative going in your company. With all tech advances, new challenges arise. For example, A significant concern with implementing automated systems and data flow is cybercrimes. Ransomware takes on a whole new meaning when the perpetrators take over an entire factory remotely and hold the factory for ransom. The cybersecurity industry is booming right now, and for good reason. Companies looking to deploy IIoT and Industry 4.0 tech must consider cybercrime risks and mitigate them with a cybersecurity strategy. Understanding the risks of fully automated systems enables companies to develop a strong cybersecurity plan. IT technology is the means, not the end. If Industry 4.0 was a garden, IT infrastructure is like a hose, and data is like water. The goal is plant growth. To grow, a garden requires water. Likewise, for water to get to the garden necessitates the use of a hose. The goals of Industry 4.0 are to increase efficiency, cut costs, and improve customers' lives. To enable automated technologies, we must have high-fidelity data. IT infrastructure is vital, but it is the means of moving and storing data. There's been much emphasis on IT environments and equipment, but we can't lose sight of why we are implementing new systems. Reliable network capabilities are valuable if they facilitate the collection of relevant and accurate data.